In part 6 of section 8, we're going to be talking about applications for the linear system. So example 8.7 is going to go right into one of those application problems. It says find two numbers whose sum is 34 and whose difference is 10. So the first thing that I'm looking for when I read through a word problem narrative is I'm trying to find, well, what is it I'm supposed to be finding? And in this case it says we need to find two numbers. And then it talks about the conditions that have to be satisfied on these two numbers. So if I know I have to find two numbers, then that means I have two unknown things that I'm looking for. Sounds like two variables. So once I establish that, I will define what my variables are. So I'm going to let I'm just going to use x and y here. I'm going to let x comma y be real numbers. I don't know which real number they are, but I know that x and y would have to be real numbers in order for them to sum to be 34 and for their difference to be 10. That has to be real numbers. So we'll start with that. And there's a rule here with systems that if you have two variables, then you're going to need to have two equations to be able to solve for those variables, what we call explicitly. If you had three variables, you would need to have three equations. Four variables, you need to have four equations. So that's why it's so important that you start by looking for what are you trying to find, and then identifying how many things you're supposed to be finding, and define your variables from there. So we only have to have two equations for this. And the first equation is going to come from the statement sum is 34, and the second equation is going to come from the statement difference is 10. So we're going to set up our system with x plus y needs to equal 34. There's your sum. And then for your difference, x minus y needs to be equal to 10. And with this, your system is set up, and you would then want to take the time to solve it. So solving this can be done in a variety of ways. We have the graphical method, we have the substitution method, and then we have the addition elimination method. And on these application problems, I'm never going to ask you to use a specific method. It'll be your choice. Now, the graphical method is sometimes a bit unreliable. It's just not always as precise as we need it, so I typically avoid that at all costs. And if I look at the system closely enough, it's actually set up really nicely for addition elimination. And I can go straight to the addition step with this as well. If I add the x's, I'll get 2x. If I add the y's, they will eliminate, and then my constants will add to be 44. So therefore, x must be 22. So then I think about the back substitution step. If I take 22 and let's say I take the first equation, x plus y equals 34, and I substitute this 22 in for the x, I will get 22 plus y has to equal 34. So therefore y must be 12. Now when we have word problems such as what we have here, I'm not really wanting to take my answer for x and y and represent it as an ordered pair. What I'm really wanting to do is answer the question. So I'm using a system to solve, but I'm really trying to solve a actual problem here. So I'll make a statement that says the two numbers are 22 and 12. And that's the kind of statement that I want to answer the question, because it says find the two numbers. Well, here they are. These are the two numbers. And for the check, you can do a check with the statements. It says the sum is 34. Okay, what's 22 plus 12? 34. The difference has to be 10. What's 22 take away 12? Oh, it's 10. So sometimes the check doesn't have to be done formally. You can do it informally, just from looking at the statement in the narrative and deciding whether or not the solution you have actually fits the conditions that are there.